In this video, we're going to be taking a look at 4 different ray diagrams, and we're going to be taking a look at images that are real, virtual, upright, inverted, larger, the same size, and smaller. And we'll talk about how those things are created and what they actually mean. So let's start with a concave mirror where the reflective side is on the inside of this curve. So we have the focal length, and double the focal length is where the center of curvature is at. Now, say for example, we have an object that is right outside the center of curvature. We would have some light hitting the actual object, reflecting off of it, and then striking the mirror, either going straight and then through the focus, or through the focus and then being reflected straight back. And now what's going to happen is we get an image that is created in green over there. Now, first of all, is it real or virtual? Real means that the light is actually converging at a physical position, which would be right over here. So this is real. So for a mirror, if it is an image that is created on the same side as the reflective side of the mirror, then it is real because the light is actually converging. Secondly, it is an inverted image. As you can see, the light is converging at a point over here, which flips the image, and then you would see something that looks like it's upside down. And then finally, you can tell that it is also smaller because if you compare the actual object size in purple to the image size in green, that is going to be a little bit smaller. Now moving to our next one, we have an object in front of a convex mirror where the reflective side is over here on the left side. Now what would happen is we would send a light ray straight into the reflective side of the mirror, and then it's going to diverge from the center after you line it up through this focus over here. And then also if you line it up going towards the focus, then it's going to get reflected straight back. Now there is no light actually converging on the same side as the object, so I can already tell that it's not going to be a real image. But what the brain does is if it sees a light ray coming from here, it's going to think that the light ray is coming from behind the mirror at those 2 specific spots. And then we have an area of convergence back here where the light isn't actually converging, but the brain thinks the light is coming from that particular point. So this is known as a virtual image because, again, the light isn't actually meeting that point, but the brain perceives the light to be coming from this point, hence causing a virtual image. Now, this image over here is converging on a point that is clearly smaller and upright. And you could tell it's smaller based on comparing the green image size to the red object size. And then you could tell it's upright because it is above this center line over here. So we know that it's going to be an upright image. So to sum things up for a curved mirror, if you have something that's developed or converging on the same side as the object, which is the same side as the reflective side of the mirror, you have a real image. And if you have something that needs to be dotted back behind the mirror, it looks as if the light is converging on a point behind the mirror, hence causing a virtual image. And then just comparing the sizes, you could tell if it's the smaller, larger, or the same. And then also looking at the orientation of the image created in green, you can tell if it's upright or if it's inverted. Now let's go ahead and take a look at our 2 lens diagrams. So we have an object maybe on this side of the lens, and we have some similar rules, but some rules that are also quite different as well. So we have an object over here. What would happen is light would hit this object, or it could be an object that creates its own light that is luminous, and the light would go straight and then converge towards the focus, or we would have one that would go right through the center of the lens. Okay, my lines aren't really great, but that's about as good as I can do. And then we would have an image that shows up over here. Now, for a lens, this is the real side. So the rules are flipped for a lens in a mirror because light is supposed to hit an object and go through the lens because it's transparent. So the light does actually converge on this spot. So this is a real image for a lens. And then also it is clearly inverted. And this one happens to be exactly the same size as our original object height. Now, typically you want to make sure you use a straight edge so that you get a little bit of a better gauge of what the actual size is. I can tell just through experience also that the length of this green image is going to be the same as the size of that purple object. Now, finally, we have an object that is right in front of a diverging lens. And since it's a diverging lens, we would send the light ray right into the mirror, and then we would use this focal point over here to line it up and then have it diverge away from the center. And then we can also send one right through the middle of the lens, just like all of our ray diagrams for lenses. Now what you can do is dot this one back. And if you dot this one back, you're just going to retrace over it anyways. But these clearly, because it's a diverging lens, are not going to meet. So they're going to get dotted backwards, and then we're going to have an image created that's right over here. So this is going to be virtual because the actual light rays are not converging. And then, as you can tell, it's going to be smaller and upright as well. Okay, so some rules for the lenses are this. If you have an image, created on the opposite side of your object, then it's going to be real, because then that's where the light is supposed to actually be converging if it's going to do so. And then secondly, again, if you take a look at the orientation of it, you can tell if it's going to be inverted or if it's going to be upright. And then comparing the size of our image and our actual object, you can tell whether it's the same, smaller, or larger. Now, if you're taking a look at all of our images, if you have an image that's inverted, that means it's going to be a real image. Now, for a virtual image, it's always going to be upright. And that's where the mind perceives the light rays to be coming from behind the mirror or on the same side of the object for a lens. And then also for a flat mirror, those would also always be virtual images as well. Obviously, those are going to be upright, and those are going to be the same size as the actual object. That's why we use flat mirrors to see images of ourselves. In all other cases, they could vary in size, but they will definitely be virtual if they're going to be upright. I hope that was helpful in helping you draw different ray diagrams and figure out if they're real, virtual, upright, inverted, larger, same, or smaller. Thank you for watching and listening.